What's going on, everyone? My name is Johnny Bannon and I'm your CCNA instructor for these CCNA video series. And in this video, we're going to go over a pretty important protocol that is going to allow us to synchronize clocks across our network devices and even some servers. And that's going to be NTP, the Network Time Protocol. Now, NTP is definitely one of those protocols where we could deep dive into it, but for the CCNA exam, NTP is going to be very simple. It's just a protocol that allows you to synchronize clocks across your enterprise, and there's going to be levels to which clock is the most accurate. We have atomic timing, GPS timing, and then levels from there. It's kind of like a hierarchical infrastructure of NTP or design, right? So without further ado, let's go ahead and get started. So let me move my face right there, and let's go over some NTP. So on our agenda for today's video is going to be an NTP overview, why we need NTP. So there's a reason why we need our timing the same across our enterprises and our network devices. And it has a lot of protocols have dependency on our clocks and our timing. And of course we just need synchronized time, right? Because we run on time. And then NTP operation. So how does NTP work? What is the protocol and port number for NTP? And then we'll go over configuration in the Cisco IOS. So we're not going to be deploying like an NTP server via Linux or Unix. It's going to be all iOS, of course. And then we'll go over a few NTP verification commands. And of course, we're going to have slides going over this, but we're also going to have a simple lab going over NTP. We're going to actually reach out to a real NTP server out there on the internet within our EVE-NG environment. So pretty cool. Okay, so let's go ahead and get started. So NTP overview. So the Network Time Protocol allows the synchronization of clocks and timing across network devices, kind of like we've already said. And there's going to be 16 levels of what we call accuracy for these clocks or this timing. We're going to call that the stratum levels. So 16 being the worst or pretty much unsynchronized. And then, well, actually, the levels are going to be 0 through 15, right? Because remember, 0 counts as 1. So stratum level 0 is going to be that atomic timing, or really that GPS timing, meaning this is going to be the most authoritative time source available when it's a stratum level 0. So you really don't want to like manually assign yourself as a stratum level 0 if you're not, right? And then we have how it communicates. So NTP uses UDP port, and it's going to be 123. So kind of important to know for like your firewalls, especially if you're really in a strict environment with a lot of blacklist, right? Where you have to go in and like manually say, we need this communication across our firewall. It's implicitly denied. So very important to know that as well for any of you guys that sit on the edge and manage your network's security. But again, I mean, NTP is just very simple. It's used to synchronize timing. So why do we need NTP? So it may seem obvious that all of our timing needs to be synced, but there is specific reasons and scenarios where it is very important. So many issues can arise when timing is not synchronized between devices. A few notable ones as network administrators. I don't believe we've gone over this because it's not in the CCNA exam objectives, but on our YouTube channel and in our pages, social media, you'll definitely see me do configuration like this. When we have a WAN connection here, let's say this is our HQ router. This is a little spoke office router. Maybe we're running OSPF here, right? Well, we want to have some flavor of authentication, so no one else can just come in here and be part of our OSPF domain. So authentication, right, not encryption, essentially means we need a way to authenticate each other. We need a way to say, how do I know you are who you say you are? And we do that with a key, or essentially a password. And we call this WAN keys. So this is when you can enable authentication on your routing protocols. And you do that by creating a keychain, you give it a key, and then on that keychain, typically you're gonna have what we call accept and send lifetimes. Essentially meaning that for this connection between, let's say, R1 and R2, we're running OSPF. We have WAN keys deployed, but these WAN keys, because we want to rotate passwords in all of our environments, not just our user accounts, are only going to be good, or WAN keys, and let's say WAN key 1, is only going to be good from March 1/23 to April 1/23. And there's also going to be a time on there. So it'll be like from 0000 to like 23.5959. So if we configure these WAN keys and we say, hey, WAN key 1 is only going to be available for essentially the month of March, how do these network devices know when to accept and send these specific lifetimes? Well, they do that when their clocks are synchronized. They can actually rotate WAN keys correctly or not authenticate a device if the timing's off on that WAN key. So that's just the way in networking that timing matters. And then licensing. So let's think about it, right? With Cisco's new smart licensing, timing matters very much. I mean, if we get a license from this date to this date, and the timing is off on our, let's say, SD-WAN Edge device or our SD-WAN Manager device, that license is no good. So another important scenario where timing is very important. And then Kerberos. That is a ticket grading ticket system that we use on our domains where timing has to be synchronized across the DCs and the actual TGT servers. So not really network specific, but something I've seen in enterprises I've worked in. And then NTP will allow a hierarchical structure that is going to follow a typical network design or infrastructure. So what we mean by that is, remember, the stratum levels dictate which timing is more accurate or more authoritative. So if we have this device right here at the internet edge, and these are the spokes, let's say this is HQ, these are the spokes, and we don't want them to get their timing out to the internet. We want them to build, let's say, GRE tunnels to the HQ and get its timing from this switch. Well, since these are spokes and this is the hub and this is going to be getting its timing from the internet, this is going to be a stratum 1 because the NTP server they're pulling from the internet maybe is a stratum 0. And then these spokes, which are downstream of this HQ router, are going to be a stratum level of 2 because it's essentially one hop away. So every hop you go away from an authoritative source, you go like one less stratum level. And this kind of follows that hierarchical design that we have in our network. If this is our HQ and then these are our spokes, they're downstream, right? Okay, so again, NTP, it has 0 through 16, but really there are only 16 levels that can be assigned for accurate timing, with stratum 16 actually being like, hey, we're not synchronized, we don't have timing. So 0 through 15 are going to be the stratum levels that we can use to actually give synchronized timing to our network devices. So stratum 0 being the top level of that hierarchical system, it is the authoritative time source, and it's always assumed to be accurate. You can see here that we can get stratum 0 or authoritative timing from like GPS, or we call that atomic timing. And then we'll have primary and then secondary NTP servers here. You can see that they just go down a level at each hop. So stratum 1 is going to be directly connected to an authoritative source, and that's going to pretty much act as your network time standard for your enterprise. And then stratum 2 is just decreased 1 from stratum 1, right? So then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 are just less accurate timings, but still available stratum levels. Then with stratum 16, technically being the lowest stratum level, but that's going to indicate a device is unsynchronized, which we may see in our lab environment because NTP and even G can be a little buggy. And then let's go over quick configuration. So to configure an NTP server on Cisco iOS, it's truly just one command, and it's going to be NTP master, and then the number that comes after it is going to be those stratum levels. So this one command enables that router or that Cisco iOS device, could be a switch, to be an NTP server to give out timing to any of its peers or clients. You see this command up here, this is going to manually set the clock. So in some environments I've worked in the government, your hub router, maybe on like a classified system, and even industry has this too, where they have their own proprietary systems completely sandboxed from the internet. you don't have public NTP servers that you could reach out to. So you're going to have to create an authoritative time source in your own closed off sandbox network. And this is kind of how you can do that. You can set the time manually on your router, your iOS device. And then if you do this one command, NTP master, any other device that's going to attempt to synchronize here is going to get the timing that you sent there. And remember that NTP master sets your iOS device to be a server. And this gets a little confusing, I've noticed my students, because the next command we're going to go over is the client configuration. The client configuration is essentially saying, hey, I want you to go get your timing from this source. And so that command is NTP server IP address. So what this is saying is, hey, iOS device, you're going to run NTP, and the server you're going to synchronize to is located at this address. So this NTP server command does not enable your device's NTP server. That's actually a client command. So it can be a little confusing, right? When you're actually just looking at the commands with no prior knowledge. And then the IP address that comes after is the server that you want to synchronize with. And then we have NTP authentication. So these are going to be the full command suite to just enable authentication and to put an authentication key on there. So first command, NTP authenticate, which is essentially saying, hey, if I'm making an NTP connection, whether I'm the server or I'm a client reaching out to the server, I should expect authentication. And then this is going to set the key, and this is going to just give it an MD5 hashing so we don't send that key across in plain text. And then this is saying these are the trusted keys that I'm going to use for my device, whether I'm a server or a client. So what that is saying essentially is that we could have multiple keys here. We could have keys 1 through 10, and we can say we only trust 1 through 5. Can't give you a specific use case on why you would do that, but it does give you that availability. And then this, again, is connecting to a server. And if we have to authenticate to that server, we need to add this key and then the number key command. So to say, hey, if we're connecting to this server out here at 5.5.5.5, we need to use key 1 or we're not going to synchronize. And then we have some NTP verification. So the big one here is show NTP associations. What this is going to show you is either a synchronized NTP peer or an unsynchronized NTP peer. So as you can see here, what we're actually looking for is this asterisk command right here. That is saying, hey, we have a system peer that we're synchronized with for timing. If we don't see that, then we're actually not synchronizing our clocks. So that's going to be the key thing we look for with that command, show NTP associations. Another key command that I don't have on here that I'll definitely change when I actually upload the slides to our Google Drive for our paid customers, show NTP status. And this is going to give you all the information currently in your NTP connections or configuration. Then we also have show NTP config. And this is just going to show you the commands that you've configured for NTP. Just a quick little shorthand to see what you have configured for NTP. All right, awesome. So that is going to be it for NTP, guys. And this is, again, it is a simple concept to kind of understand, at least in my mind. It's just a protocol of synchronized time with different levels that have more accurate timing or less accurate timing. Now, the configuration can get a little complicated when you add in authentication, server client on the same iOS device. We can even add in some more access control. We can add access lists to it. But for the most part, if you just want to get NTP up and running, I mean, you just need one command, either NTP master or NTP server. So pretty simple. And after this video, we're going to actually go over our NTP lab, which again, we're going to go through all these commands that I have up on the screen. So again, I want to thank you for viewing and stay tuned for our NTP lab.